denying it. We are living in the golden age of technology, and products like MXenes are only enhancing innovations. MXenes are a relatively new material first discovered in 2011. Think of it as graphene's buffer, cooler, younger sister. Because of its structure, MXenes can conduct electricity at faster rates than graphene, which is already being tested in sci-fi applications, like wristwatch smartphones and rollable tablets. MXenes, however, can take everything to the next level in fields not only including technology, but energy storage and medicine as well. So where do MXenes even come from? They're actually made of a giant crystal called a max phase, which follows the equation m sub n plus 1 a x sub n. N ranges from 1 to 3. M is a transition metal, A is a group A element like aluminum or silicon, and X is either carbon or nitrogen. These elements are layered with M and A alternating, and X decorating the hexagonal structure like Christmas tree ornaments. There are quite literally millions of possible arrangements, and it makes the max phase quite unusual. The material can't really decide whether they want to be metals or ceramics. Not that kind of metal. Anyways, like the former, they can conduct heat and electricity, but like ceramics are strong and heat tolerant. They're also pretty resistant to both physical and chemical damage, quick and extreme temperature changes, and can even be fatigue, creep, and oxidation resistant. This means that the material doesn't wear down easily and doesn't corrode when exposed to oxygen. To get MXenes from the max phase is still an iffy process. Currently, the most popular method of forming MXenes from the phases uses chemical etching. It's kind of like cleansing your face when doing your skincare routine. However, the chemical used is a really harmful material called hydrofluoric acid. Not only is hydrofluoric acid super dangerous to the worker as it can dissolve skin and turn bones to jelly, but it can severely impact the environment if improperly disposed of. This includes hurting our soil and groundwater. That's why researchers today are looking for alternative ways to make MXenes. Last year, I presented at the International Science and Engineering Fair a new, faster way to get MXenes from the max phase using materials like copper 2 chloride, potassium chloride, and your run-of-the-mill table salt. If we can make MXenes in fast and safe ways, the possible applications are endless. Some scientists are exploring how MXenes can be applied to batteries, which I experimented with last year. This year, I'm exploring applying MXenes to sweat-based cortisol sensors, which can further personalize healthcare by sending real-time data to smartphones. The future isn't science fiction. It's coming fast, and some of us are already here.